Okay.
Because Karim, we discussed before,
Okay.
the inflation will affect all prices in the same way. The inflation will affect costs and benefits in the same way, okay? But discount rate is something different. It is that if you have a certain amount of money, okay, what is the value of this money with time? The value of this money with time will change, okay?
Okay. But Professor Mali is in some projects and in comparative projects
Yeah.
بنستعمل الانفليشن.
هلا in general you can use it, but if you use it you should pay attention and it will affect cost and revenues also, not only costs.
Yes, أكيد.
Okay, so this is
Yes.
why we consider انه it will, its effect وقت اخذ كراتio it will cancel out. يعني for example here, if you consider as one factor that you can use to make your decision is the ratio of benefit to cost. Okay, if you, because of inflation will because inflation will affect both in the same way, we consider that you can drop it from the analysis. Okay.
Yes.
So one possibility to determine if a project is good or not is to find this ratio, and the largest this ratio is, the better, because if you have the benefit much larger than the cost, you will have a high B2C ratio. Okay.
Yes, أكيد. Yes.
Now, what do we mean by the financial appraisal discount rate, or WACC? Investors expect a return on their investments that would at least be equal to the rate of the interest that could be earned from similar investments elsewhere. Therefore, private investors usually use the market interest rate as the discount rate. Okay, so this is what we were talking about. So if you have, let's say, a certain amount of money, okay, uh, this money, if you invest it, let's say if you put it in a bank, you will gain you will have after a certain period of time more money. So $1,000 now is worth of a larger value after. To have equivalent value, you should have a larger amount in after some years. Or if you go back to present, the value of let's say $1,000 after 10 years is lower if you get it back to present. So from this point of view, we should consider the discount rate that will take into account the variation of the value of this money with time. Because you can consider that whenever I am going through a project, I should compare it with what would happen if I consider another approach. And for example, if I put my money in a bank, the value of my money will increase with time. So $1,000 maybe after 5 years will be, let's say, $1,300. Okay, so I should at least gain in this period the same amount to say that my project is profitable. So this is why we say whenever we study a project on a certain period of time, we should consider the discount rate I that we considered before. Now, how to decide on its value? One possibility, if you want, is to take the market interest rate as a discount rate. So I compare with other projects. So if I want to invest in any in the market, okay, I can see what is the rate used in the market and consider that this is the discount rate in my project. Okay, because I am putting a certain capital, and this capital, if I invest it somewhere else, will give me back money. So I should consider, if I want to compare what I gained to what I would have gained using another approach, let's say the market interest, I should take my discount rate equal to the market interest. So it can be said that the financial appraiser's discount rate I represents the cost of my capital. If I have money, okay, this money is for me. I can use it in the market to gain a certain amount, but I decided to use it in a certain energy project. So I should be sure that this energy project will give me a gain larger than the one I would gain in market. This is why I should consider the discount rate. Now, we should pay attention. We should take into consideration the source of my capital. Okay, so the capital can be my own capital. So in this case, I use the market interest rate as discount rate. But also, sometimes it can be the mixture of a debit. So if I take money from the bank, okay, then I should take into consideration the bank interest. While if I use my own money, so I should consider the market interest. Okay. So, for example, I can consider that any amount of money can be a mixture of debit, which is external financing, for example, from a bank, and equity, which is an internal financing from my own pocket. The debit interest rate depends on the capital market and is equal to the interest rate on the market that projects on the same risk category and similar repayment periods that we have to pay. While the capital cost of equity is equal to the return that an equity investor wants to see on his or her investment. So what we mean by this, okay? Consider the following case. If you have a certain capital and your capital is constituted by 70% of debit money and 30% of equity, okay? So you have already 30% of the amount, and you expect, okay, in order to consider which rate you should have, you should say, let me consider what is the normal percentage I can gain anywhere else. And if you are a certain investor and you are comparing this project to another one, you say, if I invest my money in this way, I am expecting to gain 8%. So to see if the project, if this other alternative that I am going through is profitable, I should consider a cost of capital equal to 8%. While for the debit, I should consider the interest rate imposed, let's say, by the bank, or if I'm taking from other institution, I should take the percentage imposed by this institution. Okay, and then to calculate my overall WACC or discount rate, I should say I have
WACC.
70% of my debit based on 5% of rate, and I have 30% based on 8% of rate. So in overall, I should do 0.7 times 5% plus 0.3 times 8%. So in overall, I should consider a value of I equals to 5.9%. Okay, so this is how we can estimate the value of I. It depends on the source of money that I have. If I'm using my money 100%, okay, so you know that a businessman, for example, can participate in several projects, several investments. So he has the option to put this money in several other projects. So let's say if you want to invest in energy, you should be sure that you are gaining more. If you don't gain more, then you will not invest in this project. You will invest in the project that will give you the highest benefits. Okay, so this is why we say we set, if you are using your own money, you should set the percentage depending on what you expect to gain. What is the expectation, the maximum expectation I can have? If you will not have, for the project you are trying to study, if you will not have more revenues, you will not go through this. You would say, no, I prefer to go to another project where I can gain more money. And if you use a certain percentage from debit, you should take into consideration what is the interest rate imposed from this debit. So if you want, for example, to pay for the bank each year 5%, then you should expect to gain more than 5% of your capital each year to be able to pay back your bank. And of course, maybe you will not be able in the first few years to pay back the if you want this 5%, but on the long term, after you reach your payback period and you start to gain high amounts of money, you should be able to pay back your bank. And we'll study also a strategy to see how we can pay debits, okay, on time. So this is how we can assess the value of I. Now, we have if you want, disadvantages whenever we want to consider the NPV. So first, the NPV is relatively easy to calculate and reflects the time value of money, and it has a high importance in energy economics, but it represents some disadvantages. First, the value of the NPV depends on the underlying assumptions of the project parameters, which cannot be estimated with certainty. يعني this is why, as I told you, whenever we conduct the analysis, we don't consider one possible discount rate. We do the study over a range of discount rates, يعني, because you have a lot of risks that are not predictable if you want. يعني. If you take the example of coronavirus, no one maybe could expect that the whole world will be completely closed for 2 years. And this will have very bad effects on the economy. Of course, not this is a particular case that will not always happen, but in general, we should take into consideration that we have risks that we are not aware of, and this is why we should try always to be on the safe side to increase our gains, so that in case we have any unexpected event, we'll be ready to face it. Okay. So this is why we cannot be certain at all about the amount of gains that we will have. This is why, to be on the safe side, we try to sometimes put a discount rate larger than the one that we expect to have. This is why we can study a range. Yani we can say, let me try, what if according to my calculation in the previous example, the discount rate was about 5%. But I say maybe I might have some unexpected issues, my gains will be reduced. So let me try, if I raise the discount rate to 10%, how this will affect my gains. Or if I go to more critical scenarios, let's say for 20% discount rate, what will happen? This will help me, if you want, to determine what is the range of discount rates I can play with. So I might consider for the what is the most critical scenario that I can go through while still having benefits. Okay. So net present value alone is not, if you want, a good indicator if we don't take with it several other indicators that we'll discuss in a while. So if we consider also that the NPV is an aggregated value, so we are adding several values, and if we have any change in one of these parameters, this will affect a lot my analysis. And in the end of the calculation, there is only one value that describes the economies of a complete project, which have a lifetime of over 30 years. So what we are saying here, it's not enough to look at one indicator to do a decision. We should develop other factors, other financial factors that can help me into making my decision. For example, we'll discuss in next slides how we can make sure to pay our debits. So we can define the debt service coverage ratio. We'll also discuss, if you want, the interval of rates of returns that I can have while being on the safe side. So what we call the IRR, the internal rate of return, that we'll discuss in the next slides. So this, if I calculate NPV and IRR and debt service coverage ratio, I can have a better decision because I will have a wider view of the economy of my project. Okay. So now, as we discussed, employing time is very critical and important. And then we can consider, whenever we take time into account, of course, the payback period will increase, because whenever we consider a static payback period, we are very optimistic. We consider that the value of the money will remain the same, which will not happen, because in general, I should take into consideration the discount rate, and the value of money is reduced with time. This is why when I implement the effect of time, what will change in my formula is that when I do the summation of the annual net revenues, I should divide for each year the net revenue, which is the difference between the revenue and the cost for this year. I should divide it by 1 plus I to the power t. And this will lead to a larger value of the payback period. Because since I am having a lower value of revenue, I will need more time to cover my initial investment. So one of the first implications of employing time and considering effect of time is to have that the dynamic payback period, of course, is larger than the static payback period. So in comparison to the static payback period, the dynamic payback period is longer, especially for renewable energy projects. So of course, if we take the example of lamps that we did together, it's fine if I don't take effect of time into account, because I'm talking about a few months. I'm not taking years. But for renewable energy projects, I need to invest through a very long period. So I should take, of course, the time effect, because if I pay, if you just consider the following case, I put my money in the bank, I will earn each year a certain amount. Okay, so the value of my money is changing with time. This is why I should consider the time effect. Now, as we discussed, it's not enough to just study the net present value. We need to develop other parameters that will help me into taking the decision. One important factor is the internal rate of return. And the internal rate of return is defined as the discount rate at which the NPV becomes zero. In other terms, if you want, it is the largest possible discount rate for which I get NPV equal to zero at the end of a lifetime of my project. So let's say my project lifetime is 30 years. Okay. So to say that I will not lose, at least, I will not lose money in case the net present value at year 30 is zero. Okay, so to not lose money, of course, no one will invest if we just have a net present value of at the end of lifetime equal to zero. No one will do it. But why this indicator is important? Because, for example, if I say what is the discount rate I for which the net present value will be zero at the end of lifetime. If I obtain, for example, I equal 40% to have a net present value of 30 at zero, this is a very good indicator. Why? Because for any value of I between 0 and 40%, I will gain money. So if I have small discount rates, so if I am able to work, for example, in a range between 0 and 10%, then my savings will be really high. Okay. So here, a lot of students do the confusion between two things. Please pay attention. Higher I, higher discount rate means lower NPV. Okay. Means higher payback period. Okay, lower NPV, payback period is larger. Okay, it's true. But a higher internal rate of return, it's exactly the opposite. If I have a high internal rate of return, this is a good indication, not like the indication of I. Because if I have a large internal rate of return, this means I have a larger discount rates interval that I can work with while still having a net present value positive at the end of lifetime. And this means that I have a more flexibility. So maybe I can invest my project, even if I take a country that is not very safe, even if the discount rate is 20%, I still can invest. So having a high IRR will lead to higher flexibility. I can invest in a wider range of conditions while still gaining money. And then if I have a small I, this is very because my NPV, of course, will be very high. Because for any rate I smaller than the IRR, my NPV at the end of lifetime will be positive. And the smaller is I, larger will be my NPV. So of course, if I say between 0 and 10%, the NPV will be much larger than between 10 and 20%, etc. But at least for a high IRR, I can reach much larger discount rate while still having a benefit at the end of lifetime. So it's good to have a high internal rate of return and a low discount rate. Okay. Any question on this? Yes.
I have a question.
Yes.
So isn't the net present value the value of the revenue and the cost, for example, at year 2?
Yeah.
عم نرجعهم to year 0 to يعني to right now.
Yes.
How are we taking it at year 30? Let's say?
Okay. Okay. When you do the calculation here, I can tell you, for example, let's say the lifetime is 30 years, okay? But if I tell you what will be the net present value at year 5, then if I tell you calculate the net present value at year 5 or at year 3, for example, you stop here, okay? And this will give you an indication of what will be your balance at year 3. But if you want to know at the end of the lifetime what is the net present value, you should keep adding until reaching year end. Okay. And when you want to assess if you want the overall gain of your project, you should know at the final year what is the net present value. You can compute for each year what will be the net present value, but the most important value is the net present value at the end of lifetime. Yani you will take all costs from year 1 to year n. In the example we considered 30 years, you will bring them all back to 0 because you are calculating a net present value. But when you say at year end, then you made the calculation for all years. But if I tell you calculate the net present value for your project at year 3, you should stop here. Okay.
And by definition, what is the net present value?
Okay. Look, I will give you a numerical example. If I go back to this table, okay? But now I will not consider that the time effect is not important. I will consider that the time effect is important. Okay. So, and I will tell you take as discount rate 2%. Okay. So take I equal to 2%. If I ask you, what is the net present value of the project at year 3? Okay. You will say the following. You say the net present value for year 3 is equal first. As we said, we should do minus the investment. So minus 10,000. Now you say for the first year, okay, I am having a revenue of $8,000 and I have costs for this year of $5,000. So I should do 8,000 minus 5,000. Okay, but now because you have time effect, you cannot just do this. You should divide by 1 plus 0.02. So 1.02. Okay?
Yes,
if you just do this and you stop, this is net present value at year 1. So this will represent for you what is your balance until the end of year 1. Okay? Now, of course, as you go with time, the net present value will increase because you are gaining more than you are losing. And the costs are smaller than the revenues. So with time, the NPV will increase. If I ask you now, compute the NPV at year 2, should add to this 8,000 minus 5,000, which is 3,000. Over now, for year 2, because you should go back 2 years back, you should divide by
1.2
1.02 square.
2.
Yes, exactly.
Yes.
1.02 square. Now this is NPV for year 2. NPV for year 3 should add 3,500 over 1.02 to the power 3.
100%.
Okay. Now, if I ask you to find the net present value of the end of lifetime, since the lifetime is 5 years here, okay? So you should add to these terms, you should add plus 3,200
الcomponent 4 وال5.
Yes, over 1.02 to the power 4. Okay. And plus 3,000 over 1.02 to the power 5. Okay. Let us see together why the payback period will be affected. Okay. Can anyone please calculate the net present value at year 4? So you will stop here. Can you do it, Karim, please?
Yes, يلا.
Yeah. So here, if you want to assess the payback period, we should compare the net present value. Of course, at year 3, it will be negative. Because when you considered a static payback period, NPV was negative at year 3. So of course, it will be negative now, since when you take into account the time effect, you need more time to pay back your system. So now we are not sure about year 4 what will happen. Okay, it might be negative, it might be positive. But of course, we'll need more than 3.156 years. We need more than this amount. So here, did you get the value, Karim?
Yes. 1423.2.
Okay. So the net present value at year 4 is 1,423. 23. Okay, $1,423. If you compare it with the net present value at year 4 for the case of no time effect, it was, if you remember, the total was 12,700, and we should discount from this the initial cost, which is 10,000. So the net present value for this case, where we don't take time into account, is $2,700, which is larger. Okay. The payback period is still less than 4 years, but it is of course more than 3.156. Okay. So from here we can say that when you take discount rate into account, for example, if I tell you instead of 2%, if the discount rate is 8%, let's say,